The cosmos is a realm of infinite wonders and profound mysteries, where celestial bodies dance in a delicate balance governed by the laws of physics. But what happens when this balance is threatened? Imagine a scenario where two planetary neighbors, Pluto and Neptune, are on a potential collision course, stirring unease among scientists and space enthusiasts alike. This unfolding cosmic drama could have far-reaching implications, not just for our understanding of the solar system, but for the very stability of life on Earth. Pluto, a small planet on the outskirts of our solar system, has always been a source of fascination. Recent reports suggest that the orbits of Pluto and Neptune may cross dangerously, causing alarm among astronomers. Respected figures such as Neil deGrasse Tyson and Michio Kaku have weighed in on this potential cosmic event and emphasized its significance. But how did Pluto end up on such an uncertain path, and what could that mean for Earth? This story delves into the fascinating journey of Pluto and its interaction with Neptune, revealing the complexities of their orbits and the potential consequences of a collision. Since its discovery in 1930, Pluto has captured the imagination of scientists and the public alike. Originally classified as the ninth planet in our solar system, Pluto was later downgraded to a dwarf planet due to its special characteristics and orbit. Despite this degradation, Pluto remains at the center of astronomical research. Its orbit, which lasts 248 years, is very elongated and inclined, and deviates significantly from the ecliptic plane on which most of the other planets lie. This unique trajectory brings Pluto closer to the Sun than Neptune for about 20 years in each orbit, defying conventional expectations based on their position in the solar system. The plot deepens when you consider the gravitational interaction between Pluto and Neptune. The two celestial bodies engage in a complex gravitational dance, each pulling the other and changing their trajectories over time. Despite the regular intersection of their orbits, no direct collision occurred due to a combination of gravitational forces and orbital mechanics. This delicate balance is maintained by phenomena such as azimuthal libration and latitudinal libration, which ensure that Pluto remains at a safe distance from Neptune during closest approaches. Advances in observational technology have allowed astronomers to track Pluto's movement with unprecedented precision. This led to a deeper understanding of its orbital dynamics and possible effects on the stability of the outer solar system. Although the probability of a direct collision is still small, it cannot be completely ruled out. This uncertainty forces the astronomical community to constantly observe and study, highlighting the dynamic and ever-evolving nature of our solar system. Pluto and its interaction with Neptune extend beyond the scientific community. The possible consequences of such a cosmic event fueled public interest. Eminent astrophysicists such as Neil deGrasse Tyson have emphasized the importance of understanding these celestial mechanics. Tyson, known for his engaging communication of complex scientific concepts, weighed in on the potential risks and broader significance of Pluto's strange orbit. He sees the reclassification of Pluto as a dwarf planet as a step forward in understanding the solar system and emphasizes that there is still much to learn about the complex dance of the celestial bodies. Michio Kaku, another great figure in the field of theoretical physics, offers a fascinating perspective on a possible collision between Pluto and Neptune. Known for his contributions to string theory, Kaku believes that studying such phenomena can provide valuable insights into the fundamental principles of the universe. He believes that the gravitational interactions and orbital dynamics observed in the Pluto-Neptune system can improve our understanding of space travel and help design future missions. This perspective emphasizes the interconnectedness of celestial mechanics and theoretical physics and emphasizes the importance of continued research and investigation. The potential collision between Pluto and Neptune is alarming, but offers a unique opportunity for scientific observation and discovery. Such an event would create significant gravitational waves and release enormous amounts of energy, providing a rare glimpse into the behavior of fundamental particles and forces under extreme conditions. This could provide valuable information for testing the predictions of string theory and other areas of theoretical physics, deepening our understanding of the underlying laws of the universe. This could provide valuable information for testing the predictions of string theory and other areas of theoretical physics, deepening our understanding of the underlying laws of the universe. Despite the distant location of Pluto and Neptune, the consequences of their potential collision are profound. Understanding these interactions not only adds to our knowledge of the solar system, but also sheds light on the larger dynamics of planetary systems and galaxy formation. The study of Pluto's orbit and its gravitational interaction with Neptune is an example of the continuing pursuit of knowledge in astronomy, encouraging future generations of scientists and explorers to unravel the mysteries of space. The story of Pluto and Neptune is just one chapter in the vast story of our solar system. The complexity and dynamic nature of the cosmos is further illustrated by other celestial phenomena such as the triple body problem and the behavior of rogue planets. The three-body problem, which involves predicting the motions of three celestial bodies based on their gravitational interactions, remains a difficult puzzle for scientists. In systems like TRAPPIST-1, where multiple Earth-sized planets orbit a star, these gravitational forces create complex patterns that can cause orbital instability and potential collisions over long periods of time. Stray planets drifting through space without a host star add a new layer to our understanding of celestial mechanics. Often ejected from their parent star system by gravitational interactions, these wandering planets present unique challenges and opportunities for exploration. Although the vast distances in space make direct collisions between planets rare, the possibility of such events influenced by gravitational forces and the chaotic nature of orbital dynamics cannot be completely excluded. Galactic mergers, where entire galaxies collide and merge, further demonstrate the dynamic and sometimes violent nature of the cosmos. These events can disrupt the orbits of star systems, which can lead to the ejection of planets or the formation of new celestial bodies. The late heavy bombardment theory, which refers to a period of violent collisions of comets and asteroids with the inner planets, provides a historical context for understanding the role of gravitational forces in shaping planetary surfaces and supplying potentially essential elements. As stars age and undergo significant changes, such as becoming red giants or forming planetary nebulae, their mass and gravitational influence also change. This can change the orbits of surrounding planets, which can cause collisions or ejections. These phenomena highlight the complex balance of forces governing the stability and evolution of planetary systems, emphasizing the importance of continuous observation and research. As we continue to observe the orbit of Pluto and its gravitational interaction with Neptune, the importance of international cooperation in space exploration becomes increasingly clear. Organizations such as NASA, the European Space Agency, ESA, and other global institutions play a key role in pooling resources, knowledge, and technologies to improve our understanding of such cosmic events. Collaborative missions and shared data have already produced important discoveries in the fringes of our solar system, and the potential collision between Pluto and Neptune underscores the need for continued and coordinated efforts. By working together, scientists can ensure more accurate predictions, mitigate risks, and harness the enormous potential for new discoveries that such unprecedented events offer. In addition, public interest in these celestial phenomena highlights the critical role of science communication in promoting greater appreciation and understanding of space science. Figures like Neil deGrasse Tyson and Michio Kaku, who make complex scientific concepts accessible and engaging, play an invaluable role in inspiring the next generation of astronomers and physicists. Their work emphasizes that the wonders of our universe are not the domain of scientists alone, but are a shared human heritage that inspires curiosity, exploration, and respect. Perhaps witnessing a monumental cosmic event, it becomes clear that our quest to understand the universe is as much a journey of scientific discovery as it is of the human imagination, bridging the gap between the vastness of space and our place. In conclusion, the story of Pluto and Neptune with a possible cosmic collision is a compelling reminder of the dynamic and interconnected nature of our solar system. The continued study of these celestial bodies and their interactions will not only increase our understanding of the universe, but also inspire future generations to continue the search for knowledge. As we unravel the mysteries of the cosmos, each discovery brings us closer to understanding the complex mechanics that govern the cosmos and our place in it.